In this video, we'll be covering the 10.2 section over the hyperbola. Right? Make sure to have a copy of your Unit 5 formulas. Okay? We went over the equation of a circle and the equations of ellipse in 10.1. Now we'll be working on the hyperbola equations, which is this middle section here. Let's cover the differences between the circle, the ellipse, and the hyperbola. Remember, with the circle, A and B are equal to each other. With the ellipse, A is larger than B. Now, with the hyperbola, we are going to see that A and B are independent of each other. So A does not have to be larger than B in this particular case. Some other differences that you will see is that in an ellipse, you have a positive between your two terms. But in a hyperbola, you have a negative between your two terms. So that means when we're dealing with the hyperbola, we always state our positive term first and then our negative term second. So if you look at these set of equations, we have A associated with the first term, B associated with the second. X is first here, while Y is second here. So if you notice on this equation, we have a horizontal transverse axis. The way that I like to remember this is that the positive term, or in other words, the first term, is going to indicate which type of transverse axis we have. Since it's the X is first, we think of horizontal. Notice on our second set of equations here A is again associated with the first term, B is associated with the second. Our Y is indicated first, not our X. So here our Y is positive, our X is negative. Our transverse axis will depend on the positive term. Since Y is listed in our first term, we can say that this is a vertical axis. That means that this is going to be crossing that vertical axis. Just like in the last set of equations, the only ones that I'm giving you here is where it's centered at H and K. So we'll continue to use H and K. Let's go back to our notes. For these set of equations here, notice that everything is centered at the origin. So that means H is 0 and K is 0 for both of these. The other thing we notice is here our foci is going to be the distance of C. So when we're looking at the center of our graph, we can see that the foci is going to be a distance of C. So here we have negative C and here we have positive C. If the transverse axis is Y, you can see that C is going to be positive or C will be negative. The vertices depend if the x-axis or the y-axis is our transverse axis. The equations are listed here, but you can see that the distance from the center to the vertice is going to be A. A new equation that we have here are our asymptotes. Now, if you notice here, we have a dashed line, which indicates these are our asymptotes. We learned this in college algebra. We'll be using these linear asymptotes where our graph is approaching them, but they never cross them. So make sure to indicate our asymptotes in dashed lines. We're also going to be using a dash box here to show our rectangle. And then if you notice, the asymptotes will be at the corner of the rectangle crossing through the center. Here are the three that we're going to look at. So this was our ellipse. Again, remember here from the center, we would take the square root of 9, which is 3, and we would apply it in the x direction. So we would go 1, 2, 3 forward, and 1, 2, 3 back. Our y direction would be the square root of 4, which is 2. So we would go up 2, and we would go down 2. Notice that here they have the drawing of the ellipse based on the vertices, but then you also see the dash box here. For our hyperbola here, we're going to be going from the center in our x direction, the square root of 9. Or in other words, in our x direction, we're going forward 3, 1, 2, 3, or back 3, 1, 2, 3. Our y direction will be the square root of 4, which is 2. So here we're going up 2 and we're going down 2. from the center of our graph. We use the corners of the boxes and draw our asymptote crossing the center. Remember, when our first term is an x value, we are going to be crossing our x-axis. Okay, so here's our actual graph. On this graph here, you can see our y-squared is first. So what we're going to be doing from the center is going up the square root of 4, which is 2. So 1, 2 up, and 1, 2 down. In the x direction, we're going to be going the square root of 9, which is 3. So 3 forward, 1, 2, 3, and 1, 2, 3 going back. Here is the exact same box. The difference is that y squared is our first term, which means our graph is actually going to be crossing our y-axis. So you can see the difference between these two. Let's go ahead and do some actual problems. Let's go ahead and graph number 1. Number 1 says graph the hyperbola, and we're going to identify the center, the vertices, the foci, and now the equations of the asymptote. Let's go ahead and start with the center. Since there's no number attached to the x or attached to the y, we can see that the center is going to be at the origin. So h will be equal to 0 and k would be equal to 0. Remember, our a is always going to be our first term. So a squared here is equal to 16, which means a is equal to 4. Our b will be the second term. So b squared is equal to 20, which means b is equal to the square root of 20. Simplify this when possible. Let me do this over here. Okay, so the square root of 20 is the same thing as saying 4 times 5. If I take the square root of 20, I can also take the square root of 4 and the square root of 5. It's going to be equal to 2 square root of 5. This is a simplified form for this. So equals to 2 square root of 5. The next thing I'm going to do is go ahead and find our vertices. So when I go to my formula here, you're going to see we have another set of equations for our foci. It's slightly different than the previous one we have. So making sure that you're using the correct set of equations is going to be important. Let's go ahead and solve for c. So c squared here is equal to a squared, which is 16, plus b squared, which is equal to 20. So c squared is going to be equal to 36, meaning c is going to be equal to 6. Now that I have this information, we can go ahead and identify our foci. Since our y squared is listed as our first term, we're going to have a transverse axis that is vertical. Here's our y squared, there's our negative. So I'm going to get my little post-it note and go ahead and cover up the other set of equations. Now, starting with the foci, I'm using this set right here. The foci. Foci is going to be h, which is 0, comma, k, which is 0, plus c. And we said c was 6. So here we're going to have 6. And h, which is 0, k, which is 0, minus c, which is negative 6. So now I have our foci. Let's go ahead and determine our vertices. I'll put that here. So our vertices are going to be equal to this equation. H, which is again 0, comma, k, which is 0, plus a, which is 4. So 4. And h, which is 0, k, which is 0, minus a, which is 4. So here we have a negative 4. So now I have my foci, I have my vertices. So let's go ahead and find our asymptotes. So the asymptotes is going to be a linear equation, and that's going to follow this formula here. So I'm going to have y minus 0, so I'm just going to leave it as y, is equal to, that plus or minus is going to be important, so make sure to write it every single time. And then I have an a divided by b. So our A is going to be 4, our B is going to be 2 square root of 5. So I'm going to go ahead and do 4 divided by 2 square root of 5. And then here we have X, and notice that H is 0, so I don't have to put it. So let's go ahead and simplify our Y, and our Y would be equal to 2 can go into 4 2 times, so here I'm going to have 2 over the square root of 5 times X. We never leave it where it's a rational denominator. So we're going to go ahead and rationalize this by timesing the square root of 5 to the numerator and the denominator. When I do this, I get 2 square root of 5 divided by 5x. And don't forget your plus and minus. So I'm going to put my plus and minus there, and I'll put my plus and minus there. So our final asymptote equation will be y is equal to plus or minus 2 square root of 5 over 5 times x. Let's go ahead and graph it now. We did say the center is going to be at 0, 0, so I'm going to go ahead and put that there. Our vertices are going to be at 0 and 4, so I'm going to be going up 4. 1, 2, 3, 4 right there, and 1, 2, 3, 4 right here. The other thing I'm going to go ahead and list is our focus. So here I'm going to be going up 6. If this was 4, 5, 6, this would be our focus. 4, 5, 6 right here. So we have our center, our vertice, and our focus. In order to know how wide it is, we need to know what our B is. Here I have it as 2 square root of 5, which I need to get an approximation. So 2 square root of 5 is equal to approximately 4.5. So when I'm drawing this one, I'm going to go ahead and go 4.5. Remember that value is underneath our x, so I'm going in the x direction. So positive 4.5, 1, 2, 3, 4.5, about right there, and 1, 2, 3, 4 and a half, about right there. So what I'm going to do now is go ahead and create my box. I'm using the A and I'm using our B. So I'm just going to go ahead and create the box. Now that I have the box drawn, it's really easy to go ahead and draw our asymptotes. I'm going to use the corners of my rectangle and draw a line going through the center. So use these as your points and then draw a dashed line. Again, corners of the points and draw a dashed line. Now that I have everything dashed, what I'm going to go ahead and do is I'm going to use my pink marker to indicate where my graph is. Remember, if you're not good at determining if it's a transverse axis that's vertical or horizontal, you can also use the foci. It's going to be going in the direction where the foci is. Here our foci is on the y-axis, so we're going to be going up. It will touch the box at this point and then approach the asymptotes but never touch them. Just like that. This next part is exactly the information that you get on your formula sheet minus the pictures. Number 2 says to graph the hyperbola and identify the center, vertices, foci, and the equations of the asymptotes. Let's go and start by identifying the center. Notice that there's a number attached to our x and attached to our y, which means the center is no longer at 0, 0. So we're going to start with the center. If you notice the equations on your formula sheet, h is going to be attached to your x, while y is attached to your k. The negatives on the formula are still there. Since the negative is here for the 4, we can say our center on our x is going to be positive 4. Here we have the positive sign attached to a y, but we really wanted a negative sign as part of the equation. So our y will be opposite of this sign, which is going to be a negative 3. So our center is 4, negative 3. Once we have the center, we're going to go ahead and solve for our a, our b, and our c. Remember, for the hyperbola, the a is always going to be the first term, and here I see that a squared is equal to 9, which means a is going to be equal to 3. For our b squared, we see that is equal to 7. So b will equal to the square root of 7. We can solve for c using the formulas we have here. So c squared is equal to a squared, which is 9, plus b squared, which is 7. So c squared is equal to 16, which means c is equal to 4. The next thing we want to do is choose our equations. Since we see our x squared as our first term, we'll be using these set of equations where our transverse axis is horizontal. So I'm going to cover up the vertical ones. And let's go ahead and label our h and k. H is going to be equal to 4, and our k would be equal to -3. Let's go ahead and do the foci next. The foci will be using these equations. It says h, which is 4, plus c, which is 4, comma, k, which is -3. And h, which is 4, minus c, which is 4, comma, k, which is -3. I'm going to go ahead and simplify. So 4 plus 4 is 8, -3, and 0, -3. This will be our foci. Now let's go ahead and find our vertices. Our vertices are going to be using this equation. So our vertices is going to be h, which is 4, plus a, which is 3, comma, k, which is -3, and h, which is 4, minus a, which is 3, comma, -3. Simplify on the next part. So v is going to be equal to 7, -3, and 1, -3. There's our vertices. Now we just need to solve for our asymptotes. We're going to be using this equation here. Y minus k. K here is -3, so that changes this negative to a positive, is equal to a plus or minus. This is really important. Make sure to include it. B, which is going to be our square root of 7 divided by our a, which is 3. So square root of 7 divided by 3. In parentheses, I have x minus our h, which is 4. So I'm going to have -4 here. Okay, next thing I'm going to go ahead and do is take this plus 3 over to the other side. So I'm going to have y is equal to, and I'm going to write out two equations. The first one's going to be our positive one. So the square root of 7 over 3, x minus 4 minus 3, because I'm taking this 3 over to the other side. The other equation that I have is going to be y, we'll call this one y2, and we'll call that one y1. y2 will be negative square root of 7 over 3, x minus 4 minus 3. These two have to be written separately, and if you could simplify it, we would. Since we have the square root of 7, which is an irrational number, we cannot distribute this in combined terms. So this will be sufficient. Let's go ahead and graph the hyperbola now, since that's what it's calling for. I'm going to start at the center, which is 4, 3, and go forward 4, 1, 2, 3, 4, and down 3, 1, 2, 3. Here's my center point of the graph. Our foci is going to be at 0, -3, and 8, -3. So here's my 0, and I'm going down 3. I'm going to go ahead and label this F. The other one will be at 8. 1, 2, 3, 4, 5, 6, 7, 8, and then down 3. 1, 2, 3. Here's my other foci. Our vertices will be at positive 1, -3, right here. I'm going to label that V, and 7, which is here, -3. So here's my V. So if we wanted to look at this equation, we always start in the center, and remember we're taking the square root of 9, which is 3. That's going to be going in the x direction. So if I went from here, I can go 1, 2, 3. There's my vertice. 1, 2, 3. Going back, there's my vertice. I don't know what the square root of 7 is, and we just need that for approximation. So the square root of 7 is going to be approximately 2.7. So in our y direction, we're going up 2.7 and down 2.7 from the center. So 1, 2.7, maybe about right here, and then down 1, 2.7, about right there. So I'm going to go ahead and create my box. Use your straight edge to go from the corners of your rectangle through the center. This will be our asymptotes. Since we have our foci here, let's go ahead and draw our graph. Remember, when you're graphing the graph, it's going to approach the asymptote but not touch it, but it will be touching that vertice. Okay. On the other side, the same thing. It will start at the vertice and then approach the asymptote but not touch it. And this is approximately what your graph will look like. For number 3, it says to write the equation of the hyperbola in standard form. This is very similar to what we did in the last section where we completed the squares. We always want to put the negative variable that is squared as our second term. So in this case, I'll be choosing to put the 5y squared first. So I'm going to combine my terms. 5y squared minus 80y plus some number minus 4x squared minus 40x plus some number. All of this will be equal to, and then take this constant over to the other side, which means it'll be equal to negative 200 plus 2 numbers. Since we'll be adding 2 numbers to this side, we need to add 2 numbers to this side. Remember, you never want to have a coefficient other than 1. So we're going to have to factor out this 5. So 5y squared minus, we're going to just divide 80 by 5, which comes out to 16. Don't forget to include the y also, plus some number. Minus, we want to factor out our 4 as well. In the parentheses, we will have x squared. A negative times a positive will give me a negative, so this will be a plus 10x plus some number is equal to negative 200 plus 2 blanks. Now what we're going to do is go ahead and take our middle term. So here we have a negative 16. Remember, we divide that by 2, which gives us a negative 8. Square that, and we get a 64. This 64 goes in the first blank on this side. However, remember that we're not just adding 64 to this side. It's going to be 5 times 64, so I need to multiply this by 5. Use your calculator for that part. I got 320. 320 will go on the other side of the equal sign. Let's do the same thing for this part. Take your middle term, in this case a plus 10, and divide it by 2. That got me a positive 5, which I then squared, which gave me a 25. This 25 will go in this box right here. Remember, we're not adding the 25 to this side. We will actually multiply a negative 4 times the 25. So 25 times negative 4 gets us a negative 100. So I need to add a negative 100 to this blank. Let's go ahead and simplify. Now that I have it written like this, all I'm going to do is bring down the terms. Here I have a 5, and then remember we use this set of parentheses here, and all we need to do is add the variable associated with it. here we have a y, so I'm going to add a y in front of that negative 8. So y minus 8 squared minus 4. This is a variable of x, and I'm using this part right here. So x plus 5 squared is equal to, and then now I just want to go ahead and add all this together. The negative 300 plus a positive 320 will get me a positive 20. Remember that this is not in the standard form. We want the standard form always to equal to 1. So what we need to do here is divide everything by 20. Make sure to simplify your fractions. So 5 over 20 is the same thing as 1/4. Keep the numerator in parentheses. So y minus 8 squared over 4 minus 4/20 is the same thing as 1/5. Keep the numerator in the parentheses. So x plus 5 squared over 5 is equal to 1. This is going to be in standard form. Number 4 says to determine the standard form of the equation of a hyperbola with the vertices at 3, 0 and negative 3, 0. The asymptote is y is equal to plus or minus the square root of 3x. Alright, first thing I'm going to do is go ahead and graph our vertices. Here it says it's going to be at 3, 0, so I'm going forward 3, and I'm going to label that V. I also have a negative 3, and I'm going to label that V as well. I can easily determine that the center is at 0, 0. So C is going to be 0, 0, which means H is 0 and K is also 0. Now what I want to do is go ahead and check my formulas. Remember that the vertices are going to be along the transverse axis, and since it's along the x-axis, we have a transverse axis that is horizontal. So I'm going to be using our first set of equations here. If you want to know what the distance between the center and the vertice is, just go to the vertice equation. Notice here that the vertice is always based off the distance from the center. Since we know that the center is 0, 0, we can see that here we're adding a and here we're subtracting a. Our a is going to be the distance between the center and the vertice. So here I can say a is equal to 3. The next clue that we have here is our asymptote equation. If I look at the equations for the horizontal transverse axis, I can see that our asymptote is going to be equal to y. Remember here, k is equal to 0, so I'm not going to include that, is equal to plus and minus b over a, and then x. H is also 0 in this case. Here I'm also given what the asymptote equation actually is. So I'm just going to say that our asymptote equation is also equal to plus or minus the square root of 3 over 1. The reason I did it over 1 is because I can see that this is in a fraction form, so I want to make this in a fraction form also, and then times x. So when I'm looking at this, I can say that b over a is equal to the square root of 3 over 1. Since I know that a is equal to 3, I can substitute a is equal to 3 here. So I can say b over 3 is equal to the square root of 3 over 1. To solve for b, all I did was multiply by 3 on both sides. So I get b is equal to 3 square root of 3. Remember, our goal here is to write the equation in standard form, and it calls for the center, which is found to be 0, 0. So h is 0 and k is 0. We also needed to know what a squared was and also b squared, and I have both of those as well. So I can just use this formula to go ahead and write down the equation. I have x squared minus y squared. In the denominators here, I can see that a is underneath the x, and we found a to be 3. So 3 squared will be 9, minus, and underneath the y will be our b squared. Here, if you notice, we only have b. So if we were to do b squared, we would have to square everything on the other side of the equal sign as well. So b squared is going to be equal to 3 times 3 is 9, and the square root of 3 squared is going to be 3. So 9 times 3 is 27. So I can put a 27 underneath the y. Don't forget to equal this to a 1. This is going to be our equation of the hyperbola in standard form with the vertices of 3, 0 and negative 3, 0 with this asymptote. Okay, that concludes the 10.2 worksheet. If you have any questions, please let me know.